What is a derivative really? A derivative answers a simple question. How fast is something changing at this exact moment? Think about driving a car. Your speedometer shows how fast you're going right now. That's a derivative. It's the instantaneous rate of change. Let's see this with math. Here's the curve y equals x squared. If I pick a point P on this curve and another point Q nearby, I can draw a line between them. The slope of that line tells me the average rate of change between those 2 points. But what if I want to know the rate of change at point P alone? I need to make Q get closer and closer to P. As Q approaches P, the secant line approaches the tangent line. The slope of this tangent line is the derivative. For y equals x squared, the derivative is 2x. At x equals 1, the slope is 2. At x equals 2, the slope is 4. The derivative tells you the slope at every point. The formal definition uses a limit. The derivative of f of x equals the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. For x squared, this simplifies beautifully. Expand x plus h squared, subtract x squared, divide by h, and take the limit. You get 2x. The derivative is the instantaneous rate of change. It's one of the most powerful ideas in all of mathematics.